the man, the myth, the legend, layer 4. So layer 4 is probably one of the easiest layers to comprehend, really, because we only have 2 different protocols to deal with. Many of our other layers, we have 10, 15 protocols we've got to categorize in that thing. We've got different appliances we have to categorize and stuff, and really it's a lot easier to kind of understand the role of layer 4 just because there's not that much going on. It is very important, though, that we do understand it. We're going to talk stuff about port numbers, TCP communication, more about TCP communication. Really, this should all be in one section, but whatever. UDP communication, which is a lot simpler to understand than TCP, but they both have their purpose. So really, our transport layer, we're going to be responsible for the communication between applications running on different hosts, and we're really responsible for the transmission. So our reliability, or lack thereof, is going to be handled at the transport layer. It's very important. So we have what we call segments at layer 4. If you remember, layer 1, we have bits. Layer 2, we have frames. Layer 3, we have packets. And layer 4, we have segments. And if you're a fancy English major and know what segments means, that means really pieces or parts. So we can actually segment the data. We can take it apart and set it in multiple different sections and then reassemble it at the other end. Of course, just like layers 2 and 3, we're going to add some headers. If you don't remember, adding a header, that process is called encapsulation. Right? And if we encapsulate something, eventually we have to decapsulate it as well. So keep that in mind. We're going to have a header for layer 2 for, remember, our source and destination MAC address, among other things. We're going to have a header for layer 3, which is going to tell us IP information, as well as some other things. And we're going to have layer 4 headers, which are going to tell us TCP or UDP information, and the details of what we need to do. So we're going to have that header information. We're going to have We have the ability to identify, separate, manage multiple conversations. You'll see how TCP and UDP handle those differently. We can use segmentation and multiplexing to enable different communication conversations to be in the same network. So here's a great example here. You'll see we have this little dark blue diamond or triangle conversation. I assume it's a diamond, I guess. You also have this little circle conversation in there. So we're all sharing this link. We're all sharing this this way of transporting our information, and we're breaking up our conversation into pieces, right? Like the old school phone network, you would have to pick up the phone, you have to be connected directly, and no one else could use that same line. Now in today's world, we share the lines, which makes it much more cost effective for building out your networks, and really just makes efficient use of our networks today. So IP, and you might think of IP as a way to handle the transportation of our information, but really this just handles the communication of our source and destination. Where are we going? Not how we get there. So really, it tells us where we're going, and this is how we're going to get there. So we're going to specify transferring messages between hosts, and really going to specify the reliability requirements of that conversation. And this is where things get really important, because if we have an application, we need to get every little piece of data, or we don't, or we need data to go super fast or slower, or we need to make sure that it's efficient, or whatever your purpose is, you're going to be able to make a strategic decision if you're an application developer to use TCP or UDP for your requirements. So really, we just have these 2 protocols at the transportation layer that we have to deal with. TCP is going to provide reliability and flow control. This is a basic concept of TCP, is reliability. If you sat down in an interview and they asked the question, okay, so can you tell me the difference between TCP and UDP? The number 1 best answer would be TCP provides reliability, UDP does not, right? UDP provides speed, TCP does not necessarily provide the best speed. But the core really there is TCP offers reliability, UDP is not reliable. So TCP is going to track data segments. It's going to number them. So if things arrive in the wrong order, we have that sequencing, right? That number that's going to tell us how to order them in the correct order there. We're going to have acknowledgments. We're going to say, hey, I just want to let you know I received your letter, I received your information. And if we don't get those acknowledgments, we retransmit that data. And we can adjust our rate that we send data depending on our network conditions, and we'll talk about that when we get into TCP. UDP provides basic functions that's really going to be connectionless, so we don't keep track of conversations. It's known as best effort, so it's kind of like shooting from the hip. As a metaphor, there's no acknowledgement. We don't really know if the data is received, we just kind of hope it does. So on a basic level, UDP is kind of request and reply applications, stuff like voice over IP or DNS. Remember, this is just host DNS. If you're doing DNS replication between DNS servers, you would use TCP because you need to acknowledge that information. Very, very quick. That's one of the benefits of UDP is it's fast. And TCP is used really to make sure everything's arrived in the right order or is resequenced, not resequenced, but reordered to be in the correct sequence. UDP is fast. It has low overhead, which means you're not spending extra bandwidth on these layer 4 headers. It does not require acknowledgments, does not resend lost data, delivers data as it arrives. Now TCP, in contrast, is reliable. It acknowledges data. So because it does that, it's going to have higher overhead. It's going to require more bandwidth than a UDP header would. The TCP header is much larger than a UDP header. But it does resend lost data, and it sequences things, so if we need to reorder them, we can. So really, on a basic level, TCP is very reliable. You're going to get all of your water, you're going to drink it. If it doesn't get into your mouth, it's still in the bottle, and that is great. And UDP is more like dumping the water bottle on your face. You'll probably get some of it, but sometimes it's just so hot outside, you just can't help but try to get a little bit of relief there. But a lot of that water is going to be realistically wasted. And that's just the reality of this situation. So anyway, join me for section 2. We will talk about TCP in detail. We'll talk about sections 2 and 3, I believe, are going to be talking about TCP. And then we'll go into detail about UDP. I will see you then.